Hey everybody, my name is Brent Salisbury. I am a network architect by day at University of Kentucky. Do a lot of blogging and things like that. I'm finishing a book right now on OpenFlow, co-authoring that. And committer on the OVSDB project in OpenDaylight.
I am Evan Zeller. I'm an intern with Brent at the University of Kentucky working on SDN stuff. I'm also a committer on the OVSDB project on OpenDaylight.
So there's a lot, so I wasn't really sure exactly what kind of audience we have, with people kind of new to SDN and kind of curious on how people are using it, or if it's just pure developers that want to know about OpenDaylight, develop on it, and we're developing on it. So kind of starting off with our kind of how we're using it, what we see in it, the problems we see in it. There's probably more problems than anything right now, so I don't beat that too much up. Actually, the niece is the only actual vendor in here from the project, so IBM's not going to get ripped on, but everybody else is.
Wait, you have to spare NEC also because you.
Oh yeah, sorry. Yeah, so NECs. So why OpenDaylight? Lots of reasons. Obviously, open source, for one, is more than ever kind of important. We've never really had open source in networking. Features and software, not hardware. I think we all know that. Today, if you need a feature, you wait on somebody to come out of a foundry, and eventually, a couple years down the road, you get a feature. And then when that feature doesn't work, or that feature needs to evolve, you wait another 2 to 5 years for the hardware pipeline. We need vendors, they need us. Definitely believe this because SDN is not mutually exclusive of vendors, so it's kind of silly to think that they have to make a profit, obviously, but the winners of SDN are probably not hardware sellers, so hardware vendors, except for Easy Chip. I like Easy Chip. MG5 is cool. Platform is uninteresting. The platform is absolutely uninteresting. So I would say that you see Microsoft developing Office for Android. I think that's a pretty good indicator that the platform is not interesting, right? Its applications are interesting. So I don't think we're going to see dozens of platforms. I don't think we need dozens of platforms. I think at most there'll be maybe 3 or 4. So that's why I would argue that the platform is uninteresting. The industry needs control plane reference. So we have a control plane reference in OpenVSwitch. If you are developing either a soft switch or a piece of hardware, you probably go directly to OpenVSwitch, look at how that's implemented, and either use that piece of code yourself in your hardware, or use it and don't tell anybody and put it in your libraries. Multi-vendor, so the other reason I really like OpenDaylight other than just being on the Linux Foundation is there's lots of checks and balances. So there's lots of companies that would like, Cisco doesn't like the whole SDN thing, right? It's not healthy for Cisco, but Cisco is evolving because they know they have to evolve. So this idea that, OpenDaylight is controlled by Cisco. And it's just, it's kind of silly at this point. If anything, IBM's going to control something. They got to pick a platform between 2 competing vendors. So there's tons of checks and balances. I think Ed said it perfectly earlier. Go look at the commits, see what's there. That's who, deserves credit for OpenDaylight. Not the name on the, Ed was just talking about your vendor list. Not all the, the logos up there. So we had somebody, put out a controller yesterday. It's like, oh great. Well, that's helpful. Good luck. It was a great platform. They probably made money off of it. So yeah, let's talk more code. That's what we need. We need products. We need products, not really this kind of experimenting. We've got a lot of controllers. We've got a lot of platforms. But a lot of them are either somebody's PhD thesis work or the single vendor stuff is probably what concerns me more than anything. So it's an amazing community, it really is. It's like really nice people, good hippies that like to help each other. You know, no terse, one-line replies. People that genuinely want to help. Because I think we're proof of that, because my background is I'm not a developer. I'm figuring it out and learning, but I've been networked for the past 12, 15 years. So what is SDN? SDN is still the physical separation of control from the forwarding plane. That's SDN. You can use SDN to do lots of products. Some products sound like SDN, but they don't use SDN. That's fine, right? We kind of remember this is what SDN is. Want to do other things, that's cool, but this is what SDN is. Yes, PGP is an SDN. So, and OpenFlow isn't like this. I'm going to talk like almost exclusively on the first 30 minutes of this is all about OpenFlow, just mainly because that's how I can from a compute server send control forwarding of the network. So OpenFlow is that primitive today. Certainly not perfect. It's probably the easiest way to install services on the edge.
Are there any other low-level primitives?
So like,
Inspirational?
yes, the Forces was the one that came out of IETF. I know a little bit about him. So I think, like, please interrupt me throughout this. This is kind of
Oh, sorry, yeah.
No, I appreciate it. It's awesome. So your Forces would probably be the closest that I've seen. There's things like, so there's the XMPP thing too, right? So there are ways to instantiate. So there's definitely ways to do it. I just think this one has the momentum.
Well, yeah, that's the whole thing, is I'm sort of new to it, SDN and Daylight, all this, and I've seen this sort of real tight coupling between OpenFlow and SDN, and I'm getting to the point where I realize it's not necessarily, it has to be that way.
Yeah, no, absolutely. Great point. Really, this is what has the momentum. So if something else comes along that has the momentum, great. I just don't, like at this point, to go back and take another 5 to 10 years. I mean, we've been asking, for example, OpenFlow, like at academia for at least 5 years.
Yeah.
It's been around since 2008. Like, there's 4 companies that did a Genie presentation in 2008, which is an NSF funded thing.
Yeah.
Forgot the exact ones. But it was IBM and Cisco, because they're in the room, and NEC. So this is a problem. So it's a perfect transition because OpenFlow doesn't do this very well, right? Because OpenFlow is done in TCAMs today. And TCAM is slow. It runs, the fastest TCAM is probably around 600 megahertz. So if you transition that to packets per second, 6 million packets per second. So a terabyte is a lot more than 6,000 or 6 million. So that's kind of where this idea of disaggregating at the edges comes along. Like, here's how a kind of classic chassis works. You've got some kind of routing engine, then you've got line cards. Routing engine pushes down forwarding entries proactively most of the time, and that's what kind of the internals of a classic chassis would look like. And then a lot of this stuff is distributed out into the individual line cards too. So we've kind of gone from a more central model to slightly distributed in the line cards, but if you pull out that top line card or pull out that control, regardless of what those vendors are going to say, your switch will melt down. So a lot of this stuff is just consistency models, so there's lots of, I'm not a distributed systems guy, but I do know, we use a couple of those in the network, and one is the eventual consistency. So you have a bunch of network elements and they eventually talk to each other and say, agree upon this is what the state of the network is, and we all understand that. And then it changes and then that all happens again. So this is a kind of a Cold War relic. This was all done for nuclear fallout. And the Russians and so, the Soviets and the US blow each other up, we stop lines of communication. Problem is we design all of our interior networks in the same fashion. So the opposite side of the spectrum would be centralized. So you've got immediate consistency. So if I have wire, like if anybody knows how wireless controllers work or some phone platforms, you've got all the intelligence is centralized. Something boots up, attaches to that. It doesn't need to exchange anything. It's just immediately done as soon as it attaches because all that intelligence lives there. So this is probably something where we'll land, right? So it's kind of modularity. It's we're still exchanging state, but we don't necessarily need to. Every box doesn't have to hold your entire internet or your entire network. And a lot of the reason for this, maybe hopefully will become clear in a few, is that it's a whole lot easier to do services and policy and things like that. It's tough to do decentralized anything or distributed anything is pretty tough. So here's the same, that same picture, but saying, hey, this is using some other protocol to instantiate port. So instead of using proprietary backplane protocol that the vendor's using on their backplane, this is just saying, well, here, I'll do that and I'll expose it and I'll use the network or something else, some kind of fabric as a bus instead of a chassis or a stack cable or sort of things. So here's when people think of OpenFlow, they think of this, I think we're starting to get, I heard a good conversation earlier on proactive, so we'll get to that. So the first packet of the flow comes in and goes to a controller, and that doesn't scale, and it's multi-layer switching from 5 or 10 years ago. So this is really great for a lot of things, in my opinion. We're not there yet, but if you're a security guy, you can say, I want to know exactly what happens with every flow on my network. That's all security guys want, because they're evil and want to control everything and know where everything goes. So it's really interesting. It's just also very challenging. So this is what BGP kind of looks like, right? I didn't do a very good job of drawing out how those, this is basically supposed to represent two same things in a kind of bad way, but so there's one element populating another element with state. So this is OpenFlow kind of doing the same thing. So you can pre-populate all this forwarding information and forwarding tables so that a packet never goes in, because a packet, all OpenFlow is this kind of simple mechanism to do a match and then an action. So if it's already there, then you don't need to hunt to a controller. If it isn't there, then probably you're going to drop it or do something with it. It's maybe do the reactive thing. So that's kind of the cool thing, is we've never really had the ability to say, I don't want to install everything, but I want to take this one little bit of traffic or this one flow and send it to a controller or do something special with it. So here's some problems that, there wasn't an enterprise edition of Daylight. I didn't take it personally, but I'm feeling that kind of hurt. No. So it's like, in the enterprise, I think we're kind of like the lag behind as far as we do everything, but we probably don't do anything very well. We've got bizarre, we don't have the money of hyperscale, and we don't have the scale of service providers and that sort of thing. So enterprise has some, these are things that I think I was working on this morning. Problem, and it's escalated up, and things don't work how they should, and there's some link somewhere more than likely that's taking errors, and it's really hard to find. So enterprise networks and networks in general, in my opinion, are fragile. And a lot of that comes to L2 domains. So layer 2 domains are very fragile, whether it's in enterprise or whether it's in the WAN or anywhere. So we've got security models are pretty bad. Products are pretty rough, because it's a lot of trickery to try and pull the control plane out of the data plane. So if you can get the control plane in the data plane, your policy becomes amazingly better. So when you go into wireless here and you get redirected to some kind of captive portal, it looks really nice and it's really easy and clean. I'm pretty sure if you did the wired network, that's not going to be the case, especially if it needs to be at scale. So tooling's tough. virtualization, we have MPLS. We have network virtualization today. It's in the form of MPLS. We use that religiously at my work because we have to have path isolation and tenant. Whether it's credit cards, whether it's hospitals, HIPAA, and all these sort of things. The problem is it's expensive, so it's more hardware, and it's still not very flexible. There's no idea of the application in today's networks. So when you hear application awareness, it's just how do I understand the L4 and the header? If I can look at L4 and I can correlate that down, I can take these sets of ports and figure out what kind of application it is. That's kind of the best we have. Alternative is deep packet inspection, looking at payload, which we just don't have hardware for. Maybe never, and cost. So this is how we provision and networking. You go out and buy 10 times more than you need that day, and you're hoping you grow into that. So it's kind of a broken cost model. And then when you maybe get the money to replace it, it's, you're maybe in this trough of despair here where everything's broken and oversubscribed and you don't have capacity, and then money magically appears. So this is much more of a scale out. So the first one was a scale up, and we were kind of talking about that earlier. But you can scale up, you tend to over provision with scaling up, whereas scaling out, just like in compute or storage, you stay much more aligned. And this is kind of where we are today. So the more stuff you buy in computing and storage, typically the cost per widget goes down. In networking, that cost stays pretty linear and arguably it even grows. So the bigger your network, the more expensive it may very well be to operate. So just, I'm throwing in some stuff for in case somebody doesn't know, or hasn't really kind of thought about. When you hear tuples, these are just header fields. So you have this kind of action and then some kind of action. So it's pretty simple. So OpenFlow though is definitely not for, the network operators shouldn't be out programming flows because that would be really inefficient. It would be worse than going out and programming a network with static routes. So there has to be a dynamic nature to all this, just like there is today. But definitely even more so because your complexity just goes through the roof when you when we're adding this whole L4 addition. But it is kind of nice to be able to say, I want to classify this in one pass. Right? So today you classify L3 with an access list, classify L2 with maybe you would classify L2. And then L4, you just, it has to go through a firewall. So Evan's going to talk about some of the problems we've run into with, as he sits around pushing flows manually in all day.
Hello. So about 3 months ago, Ed's laughing at me back there.
Not you, I'm laughing at the whale, who is the devil.
Oh, yeah. So 3 months ago, I was your average CS student with, my background in networking is a high school Cisco class on here's how you configure a switch, which I didn't really learn anything in there because all we did was replace all the mailboxes around the school whenever they went down. So I think 3 months I've been working with OpenFlow and SDN and stuff. So I think if I can do it, then any of the guys in the software industry can jump right in on OpenDaylight. So encourage that. So yeah, in the lab, the biggest pain in the butt is VLANs, right? So we have an existing network. Say we have 2 buildings on different VLANs. We don't want to go in there and rip out all the networks and re-address everything. So we've been looking at ways, how can we get from one VLAN to the other? What you run into is ARP, right? So the host is ARPing for his gateway, and if you're not using a routing protocol, so you need to rewrite onto a different VLAN to get across to the other VLAN, right? So you're kind of rewriting onto a backbone. And the issue that we run into is that kind of kills ARP, right? So, I mean, what we've been looking at is having the controller know about hosts. So you can, if you want to, I don't know, what's the next slide?
And then the other is just spanning tree, ECMP
Oh, yeah.
blocks.
So we experimented with, so we had 2 DPIPs on one box, right? And we tried putting a loop in there and to get between VLANs, and spanning tree just got a lot kind of headaches with that. But yeah, so having host information in the controller and being able to build paths on that is, I think, really the end goal.
So another, that's probably a pretty popular use case in R&D, so in research and education, is the middle. So the middle box is really expensive. And if you look at middle boxes today, they're 9 out of 10, 32 cores or some numbers slapped onto silicon. So, particular example, if you are a Prism and you're watching terabits and terabits of traffic, 33% of the internet is Netflix. Should you be inspecting Netflix with expensive silicon? Probably not. But how do you take that traffic and say, I want to classify it as this, and I want to go around the really expensive tapping policy application? So in this case, it could be something along the, I got those reversed, so that should actually be a DMZ. So yeah, firewall will go trusted and then untrusted. But the point is whether it's workloads that have science experiments and stuff like that in university, or if it's your provider and you have a bunch of Netflix traffic that you'd rather not push through your policy inspection engines, then it's pretty easy to start queuing off flows. Doing it otherwise is, so you have to have application visibility. I mean, CDNs now, there's really no way to classify applications without looking at L4, because you can't just say, oh, I know this, this prefix is Netflix, so I'm going to classify that and put it another way, because it's going to be on CDN, and those change constantly. So path selection is something that's interesting, not just for research, but I think there's a lot of potential there. So, there's lots of different metrics. I mean, these are just simple examples, right? Where you've got shortest path algorithms today that you may want to override, or you just may want one particular application to go over some bizarre link for any reason, time of day. So a lot of this, though, can be done in today's, using today's primitives. I would say they're not, because it's not being programmatically done. So, when I hear, oh, we can do that today. Okay, well, why don't we? Right? It's like, we can do it today, why aren't we doing it? 9 times out of 10 is because you'd have to hire and double the staff to go out and do this policy. I really think that's where the networking professional starts to move up the stack. So get out of plumbing and get more into policy, because that's the value of the network. So just some kind of, there's lots of problems with just kind of raw primitives today. So when we start talking about decoupling control, I think somebody said it earlier on the panel, and said, well, I don't need anything on the box. It's easy to say, but there are times when control on the box, even at the edge, can be helpful. Some of these things are being addressed theoretically in the multi-table pipeline groups, and you can have these triggers. But just something as simple as a link going down, the controller has to, there isn't this sense of, well, this path has gone away, so since this path has gone away, I'm going to start using this path. Because that's control logic that would have to live in the switch. So that would actually have to be a controller saying, okay, remove these flows that are sending me this way, and now install flows that send me this way. With some of the new group tables and things like that, it should address that. So you can almost set up, if you're familiar with like LSPs or traffic engineering and MPLS side, you can say, here's my primary path, and then here's my backup path that should trigger if my primary path goes down. But that doesn't exist today, that I've seen. Topology Discovery is kind of a hack. I mean, it works, but we're just sending LDP frames. So LDP is something that embeds discovery and sends it out to the neighbor. In this case, though, what it's really doing is it'll send out the discovery. The controller says, okay, everybody send out LDP. This is what's being done in OpenDaylight also. So everybody send out LDP out all your ports, and then if the neighbor hears it, so the neighbor does that too. So as soon as he gets it, he's going to punt those LDP ports up to a controller, and then the controller just builds a graph off of that. So he's going to say, well, you heard it from this port, and you heard it from this port, here's the packet ID, take that value and correlate it. So you start to build out your graph. Integrating SDN is tough. I think part of it is just because of how I've looked at networks, or, been doing networks for a long time, and that's how I see networks, and some of the rules don't necessarily apply, so you kind of have to unlearn a little bit. There's kind of two ways. So islands, so you'll have this SDN island that could be an overlay or a physical network, and then you'll have your regular network. So gateways are an obvious solution, and the other, I tend to talk about OpenFlow normal quite a bit. Just after this, but so just different ways to kind of start conceptualizing how do you integrate SDN, particularly in hardware, because we have 90,000 ports, and probably less than a third, or probably 20% of those are in the data center. So I don't really have a V-switch on the edge, I have real hardware on the edge. So there's lots of different ways. You can either just do separate physical networks, you can take one box and carve it into multiple switches so they look like they're just standalone. Or probably most interesting is how do I get all this into one pipeline and have one data path ID. Normal forwarding. So this is kind of cool because this says match anything. So these, I should have said, so like a ternary lookup is a match, don't match, or I don't care. So it's an expensive lookup also because it's not binary and you're having to process a third field and just everything automatically goes up. And it's all done in one clock cycle, so everything comes in. Typically it's done in TCAN, but it can be done in trees and different ways. But this is just saying match any traffic and send it to the normal forwarding pipeline. So that's the normal L2, L3 access list clause pipeline. So I can take a regular switch that has an OpenFlow agent, push in a flow rule that says act like a normal switch, and it just works like a normal switch. This is a little bit more what it looks like. So today, match anything that comes in that's a broadcast and send it to the normal forwarding pipeline. So from there, we just do the normal L2. So ARP's another one that I haven't touched on. ARP is something we kind of take for granted, I think, in networking because it just, it's ARP and it works. But the biggest problem of OpenFlow, or the biggest problem with SDN that things like OpenFlow can potentially address is the L2 problem. Because, so L2 today, when you say I need to talk from, on the same VLAN, and I need to have one host talk to another, we just flood it. And we say, okay, send it out every single port you have, and hopefully somebody's going to reply. So there's a lot of solutions you're going to have that's going to intercept that ARP. It's going to look it up in a table, and it's going to set up either a tunnel or some kind of flow path directly, as opposed to walking out from the side of your house and screaming down the street instead of looking it up in a phone book.
Well, Brent, I mean, the reality is that most of the time when hosts come online, they will do a unsolicited ARP broadcast of their address, so they pre-find the pump. And so it should be the exception where you actually have to flood on our request, right?
Yeah, no, absolutely. So this is just a really kind of coarse block diagram, absolutely. So it's solving that problem, and so sometimes things don't do gratuitous ARPs, and
right.
But for the most part, I think that you capture it on one, and I think, and I guess the angle that I come at from is that, so in the data center, it's really easy to say, if you're not registered, or if you're not supposed to be here, drop it. But everywhere else, it's kind of hard to, especially with guest networks and things like that, just, you can't register, because if you register, then customers hate you.
You know, one of the questions that comes to mind here, we talked about how we don't want hardware to specialize features and that sort of thing. But what about when you talk about things like table sizes, like you know, the number of, I'm curious, maybe you'll get to this, but about how do we garbage collect flows, right? What happens when we have so many flows that there's no room in the tables and hardware any longer, right? Isn't that a useful thing for a vendor to put a larger table size, right? And then there's the value add for that vendor.
Yeah, definitely. Might have one close, so I'd like to visualize exactly what you're talking about. So like this is kind of this ideal pipeline, because this is kind of an overflow pipeline. So if you can get hardware that starts to match this, it starts to make a lot of sense. It's basically lifted from like an Intel from 6000 PDF. So it's, but table size in itself, how do you, I mean, I'm going to be curious too how that's solvable, because if you, because at some point you have to say, oh, you can't install more services here. So if you're using the edge as a firewall and you're instantiating firewall services there, what is the notification that says, I'm almost out of space? Because that's not being baked in. And people just aren't talking about it because everybody's so focused on software. And I think you're absolutely right. So you can start with things like masking, flow compression. So if you had a 10 tuple that was only doing a DMAC, destination MAC, and a destination VLAN, well, that'll be compressed and stuck into CAN. So it's doing a binary lookup instead. So now you're leveraging existing CAN. So now you're well over 100,000 rules if it matches this kind of profile of a switching flow as opposed to more of a services flow that's populated with L2 through L4. So that's where some of the scale is going to come in hardware, is about leveraging CAN. That's probably one of the biggest problems in hardware. The other problem in hardware is definitely going to be flow mods per second. So when we start talking about hardware and memory, so the table size is going to be one, but the other is, in order to take a flow from a controller and install that into memory, that's a CPU cycle. So flow mods per second are typically anything with an NPU, so like NPUs are coming back in fashion now. Sorry, easy chip. So they're cool because it has this processing capability that's going to be able to do stuff, in the thousands as opposed to in the hundreds. Because if you look at the average switch today, it's got a PowerPC 500 megahertz processor on it, or lower. So you got more on your phone. So we're starting to see quad core stuff go in. Some operating systems are single threaded still. So can't even take advantage of that. When I say operating systems, like network operating firmware. So yeah, great question, thank you. Mac is just another easy use case. So new person comes on, and this is just something off the top of my head, but the neat thing is kind of this creativity that you've never really been able to do. And you say, I wish I could do that. And now you can just say, let's go code that out and do a proof on it. So you can say, I want to capture traffic, and you push it to a captive portal. To things like Mac today, you basically run web servers and things like that in your edge switches. It's probably not a good place to run web services and things like that on PowerPC CPUs. And then so I threw this in here down at the bottom just because I love, if you look at a wireless controller, you see all this amazing data because it's central and it sees everything that comes through. And I can never tell you the percentage of clients and the hours and the total transfer traffic and payload that they put on in a window. It's impossible to get that kind of information from a fully distributed network. Whereas here, control plane is in data plane, and so it's able to do it. I think the value of being able to see analytics like this is going to be enough to drive someone to innovate on the hardware side to get that done. At the end of the day, I think analytics is probably the biggest promise of this, because that's where we start getting these self-mutating or based on predictive analysis now go out and do traffic engineering as opposed to coarse thresholds that say, well, you hit this metric, and now somebody needs to go touch the fingers and redirect traffic manually. So kind of just data center today, north-south alignment, we push everything through central boxes. This is kind of getting into network virtualization. So if I can just disaggregate that kind of stuff to the edge, I start saving lots of money. So I think this is probably one of the biggest drivers, right? So this is a systems guy that says, I need network resources, and here's what he's used to. Right? He's used to this stack that makes that pretty easy to do. So he doesn't really want to hear about how hard it is for us to plumb VLANs across the data center, or why we can't plumb a VLAN across the data center because we don't want the data center to melt down. So he can do bad things like demotion. So this is a concept that came out of R&D of slicing. So this is something we're doing at the university as far as, so we basically have a researcher that wants to do any kind of experiment on the network. Say, I need a topology and I want to control that topology because I want to run experiments on the production network. Because today you would either emulate it with something like Mininet, or you get go buy a whole hardware lab and try and replicate your production environment, which we can't even, we barely buy 2 switches, much less the whole topology. So the neat thing about it, I think, is this idea of self-provisioning. So if you have a global network and you have a global tenant that wants to manage their own network, if you could virtualize that network and say, here you go, here is a piece of your network, and do whatever you want with it, do whatever policy you want with it. Now this isn't easy arbitrating any of this in the middle, but I think that's something that can happen with software. And so we never really had this big kind of shift from, we never had this corner case network architecture to data center and then totally different service provider and enterprise. Probably the biggest difference has been MPLS, and so there's a little bit of that in the data center, but it's much more predominant in service provider and in campuses, or in enterprise campuses. So I think as hardware starts, we used to look at GRE tunnels as a big hack. If you had a problem you couldn't figure out, you could go put up a tunnel. Now it's like the answer. So I think we'll probably look at just doing tunnels in a campus environment and having your, what we call VTEPs today, possibly be hardware as opposed to, because the problem is if you have a 10 switch hop between 2 endpoints, you're now mapping either flows or whatever, this custom forwarding, however you want to do it, you're going A to B to C to D to E to F. If I can extract that complexity and say, I just want to go from A to Z, and I don't want to worry about what's in the middle. So we're starting to see some of the tunnel encapsulation support and top of racks. So I think there's an interesting potential there to start dropping the price of these traditional distribution boxes that, you know, to get scale, achieve scale, you're running MPLS on, or not, you can take a top of rack and abstract out things between. So I kind of like, so like within FB, I think, so network function virtualization, all it means is here's how service providers are going to take COTS, so just off-the-shelf servers, and funnel, redirect traffic through them to do things like anything you used to do in a black box, theoretically you should be, they're going to be going to do an x86, and so it's a total CapEx thing. But if I can capture, so the neat thing is I can say, I just want to classify this one particular application, and I want to funnel it through something, or I want to do whatever, I want to do a custom path with it or anything else. I can just pick off that one piece, because honestly, especially in a routed network, most of it works just fine. I mean, there's not like huge problems with, I mean, the internet's probably easily the most distributed system, successful distributed system in the history. So I think it's a pretty small amount of things that need to be solved. So it doesn't necessarily mean boiling the ocean. So I'm really kind of focused on how do we find these incremental paths to starting to consume some of these services. So the edge makes sense because it's at the disaggregate. Definitely not my idea. So if we can get to this kind of abstraction, now everything just looks, particularly in our data centers, like we have a need for this today, so in hospitals, multi-data centers, and they need a VLAN from one data center to another, and it's just something we can't do because we can't, it just increases fragility every time we do that sort of thing. So if I abstract that center, the center network, now everything just looks directly connected. So this would be, this is, in my opinion, it seems to be what the data center, and you can swap it out, so this isn't endorsing anything or anything like that. So this could be a regular physical switch also. But the neat thing is, for a developer, you don't have to worry about mapping A to B to C to E. You just say, match this and send it to this host, because everybody works directly connected. And kind of went through the hardware. Only other thing would be is this. So with OpenFlow 1.0, you had just a single table. So if you matched one thing, that was it, and then you're punted out of the pipeline. So there's a Cartesian problem that comes along with that, and lots of math stuff. There's lots of math problems with this too, though. But the neat thing is, if it can be done at the performance that we need, it's really powerful because you can say, after each table, I'm going to match on something, and then do an action, mutate into something else, and then go match again based on that. And it gets kind of insane on what you could actually do with it. Cook dinner, do your laundry. So just kind of transition a little bit to the software side. So like, here's what we had in software, and here's what we had in network. So we've never really abstracted, we kind of stayed at the low level. And it's not that there's a lack of smart people in networking by any means. It's, you've got this exponential Moore's law, and you're doing millions of packets, millions of things, transactions per second, and that's a really hard thing to do. But we just need to start building out these abstractions. So I like the concepts in software development are really similar to the concepts in networking and scale and everything else. So basically in Daylight, it's modular, so we expose interfaces, and that's where everybody attaches to. So rather than just having a big blob where everybody can talk to anybody, you maintain modularity through exposing interfaces. So I mean, just a kind of generic example from our OVSDB project. So we hide some of this and expose it only where it makes sense. So kind of where it applies to the network, it's kind of the same concept, right? So abstract the stuff that's irrelevant. So if we can hide irrelevant data, we're going to make things simpler. So Ed beautifully went through this. So OVSDB, I'm going to do this, and then I'm going to hand off to Evan for the nuts and bolts. But basically, this is what allows you to build out tunnels in the data center and modify configuration of the soft switch data plane. But also, OVSDB is going to get implemented in a lot of hardware. So gateways, you're starting to see gateways that are actually, they run OVSDB to integrate into that overlay fabric. One interesting thing is, Arista actually has, not to get into a vendor, but I just kind of found it interesting. So I've been trying to figure out how they were doing L2 learning at the gateway edge, and they're actually programming the data path with OVSDB and saying, here's the key value of a MAC address that lives on this VTEP. So it almost feels like a distributed system. Because we should totally be agnostic about the protocol.
So I'll just briefly go over some of the, I won't get into too much of the goofy stuff of the OVSDB protocol, but basically it looks like a big database with a list of methods here that manipulate the database. So, I mean, list databases, get schema and echo are pretty much what they sound like. So get schema is type information. List database is just going to be list of strings of each database that you have. Default is OpenVSwitch. So and that one's already, whenever you start up OpenVSwitch, it's right there. So you have monitor and transact are the big chunk of everything. So initially you're going to send a monitor request, and every time there's a change in the database, you'll get notifications, an update notification back with the UUIDs for bridge, interface port, whatever you created. Yeah, so here's some of the tables and how they're related. The OpenVSwitch table has exactly one instance in it. So it has a list of all the bridges, and it also points to the instance in the SSL table and manager table is optional. So the SSL table can have some keys in it, public-private keys. The manager table holds pretty much, I guess, the IP going back to the OVSDB client. So it could be pointing back to data that says this is your manager. There's a similar table called controller for the bridge, points to controller and says this is where you go for your OpenFlow configuration. So the bridge has ports. You can configure NetFlow and SFlow for your network monitoring. You want to do that, and your OpenFlow configuration. Flow table is so you can set a limit on flows, and if you overflow, you can set your policy for that. So you can evict current flows that are there, or you just drop the flow that you try to add. Some things like that. And then you have port and interface. Port can have multiple interfaces. That's basically for port bonding. You can set your VLAN tag on a port, and then the interface is the hook into the kernel and how you relate to the physical device. And here, just for completion, the list of all the OVSDB tables. I think the ones that I mentioned, quality of service and queue, those are related. So the queue is just output port queue, and that goes into the quality of service, and then quality of service gets related to the port table. So you can have quality service per port. And then I guess I thought it would be a good idea to talk about how things are referenced inside the tables. So these are universally unique identifiers, UUIDs. An interesting thing is that OVSDB provides the capability of referencing within the OVSDB transaction. So you can make a transaction where you create a bridge, and then you can add a port to that bridge in the same transaction before the UUID is generated, because it's all generated on the OVSDB server side. So we don't handle any of that. We can reference it. So I think that's pretty cool. And this is how we're implementing OVSDB in our project. So the left-hand side there is pretty much the OpenDaylight controller. I think we're the only project right now using the configuration service and the connection service. So, well, maybe not your connection service. Somebody else might be using that. But the configuration service is exposing northbound APIs for creating bridges, ports, setting VLANs for those ports, and OVSDB plugin contains a full representation of the OVSDB on our side. So we're working on demarshalling the monitor request response into a bunch of POJOs. Brent's been working on that for a while. So once all that's working and we get the caching working, so you'll do one additional monitor, and then you have a completely consistent representation of the OpenVSwitch database on the OpenDaylight side, and that can be leveraged in many ways by different projects or whatever. Yeah, I think that's it.
So, I've had some, I've been using OpenVSwitch for a while. This OVSDB server database, is it modified in any way from what I get when I just do a git pull on OpenVSwitch from their site? Did you guys modify it in any way? Or
No. Basically, we're just implementing OVSDB client.
Okay.
So
and then you said that OpenFlow protocol requests and they get instantiated.
Right. Well, so OpenVSwitch database doesn't deal in OpenFlow, right? So
No, but you use it like an OS. There's like OS, OFCTL or something, OVS, OFCTL.
oh yeah, OVSDB CTL, right?
So you can just manually put them in, so you guys.
Yeah, so you're on a command line, you're doing your OVSDB CTL.
Yeah.
Underneath that, it's just talking OVSDB to the server.
Right.
Yeah. So we're just implementing that.
So you bypass that and just went straight to the,
Yeah, so it's JSON RPC requests.
oh, okay,
Yeah.
okay, great.
Oh, yeah. And so it'll listen where like OpenFlow is from the element, then attaches to the controller. It's
Right.
vice versa. So the controller actually is the client that attaches to the OVS.
Okay,
So
okay.
pretty good. Pure.
That picture there actually was probably the most useful picture I've seen today. That was great. I finally get it now. Okay, yeah, okay. All right.
Good, good. And then kind of just what it's doing is just setting these tunnels up as needed. And that's actually not my picture. So let them look down co-op and look very clear. Great. So kind of just to summarize, so member virtualization is this kind of core thing that's kind of inherent. It should be a commodity. And then so the early, I hate to say killer app, right? But I think the killer data center app, and it's a changes and listen to those talks. But it's here's what OpenStack is dealing with. Without this, it needs to figure out everything the controller is doing, and that's a hard thing. I tried to find a picture of Dan Windland's presentation at the last OpenStack Summit where it was basically this bowl of spaghetti on the back end and then somehow abstracting it into something clean on the front side. So from a stacker's view of it, it should just be here is the network, and then we abstract details. Because this is what we're going to be good at, is presenting these elements as kind of something that's pretty ubiquitous and it's just a network resource as opposed to 30 different drivers and everything else. That's it. Any questions or anything? Yes, sir.
Is the model to actually be able to track changes on OVS? And versus, you're really a controller, so you have all these switches and you manage them. Whereas, in OVS environment, you can't change it directly from individual. You actually support that mode of operation and you try to keep track of.
Yeah.
So you depend on being authoritative on these switches. Or
So,
switches.
yeah, there's updates that come in, so that there's a control channel that stays open. So as things change on the element, that gets passed up and it's cached on the controller.
And how do you manage them now, conflicting things that happen? Like, you expect the connection to X, Y, but somebody just tore it down.
Yeah.
And so now, do you reflect that in your system? Now you're actually going to tear it down? Or do you actually try to correct it? Do you log an error? And there's,
Oh, yeah. No, I mean, these are like all the tough problems. So, some of the logic and things like that are still, because ideally we don't do that in the plugin. Like there's a lot of, in the controller itself, there's going to be a lot of the state management, clustering, and all that sort of thing. So ideally we have a service that we just tap into and works onto us. So I think the less intelligence in the plugin itself, it's like purely an implementation, and then it gets driven up into the SAL, the service abstraction, and the services that should deal with it better than we would.
So in the general OpenDaylight.
I'm sorry, we're gonna have to take that offline. We're out of time.
So thanks everybody. We're all winging it. I know I am. So, but come join us. It's a lot of fun, and so once every 20-year occurrence. Feel free to.